Good morning, ladies and gentlemen. May I please ask you to be seated so we can begin the conference. My name is Jatin Nathwani. I'm a professor and executive director of Waterloo Institute for Sustainable Energy. Before we begin, I would like to read out an acknowledgement. We here at the University of Waterloo acknowledge that we live and work on the traditional territory of the Atawandaron, Anishinabeg, and Haudenosaunee peoples. The University of Waterloo is situated on the Haldimand Tract, the land promised to the Six Nations that includes 10 kilometers on each side of the Grand River. Good morning and welcome on this rather wet day. I know we're starting 15 minutes later just to allow a few more people to filter in. There are 300 people who've registered for this conference, so let's assume they will all filter in a few moments. I would like to just note and make a few brief remarks on the subject of the day, and then I'll call upon Professor and Dean Faculty of Environment, Andrey, to make a few remarks as well. The observation I would like to make is this, that as we look at the global energy transition in terms of finding our way to a low carbon energy future, most of the discussion tends to be around aspects of the energy system, such as whether it's solar, wind, bioenergy, geothermal, hydro, and so on, as to how to shift from fossil fuels to other forms of generation. And laterally, the discussion is also very much germane and pertinent around mobility and the transport sector, and how the transport sector may move away from fossil fuels to either electrification or some other way to get us on a path and a trajectory to a low carbon energy future. Buildings are often not talked about or don't have the kind of profile that one would like to see, that I would like to see, but it is not really recognized that buildings constitute, 35–40%, depending on the country you're in terms of the energy consumption and therefore the carbon footprint, knowing that most buildings are heated through natural gas. And so buildings provide, in my view, one of the most powerful opportunities for enabling this transition to a low carbon future, both here in Canada and around the world. And so therefore, the building science, whether it's the building envelope or how we work and live within buildings, and what we call the digitalization of the buildings, buildings talking to buildings, buildings through IoT, sensors, devices, begin to evolve a form and a shape that makes the use of energy that much more efficient in the buildings in a way that can be totally transformative. So building science, in my view, has a huge amount to contribute in terms of where we get to on the big picture issues of a global energy transition to a low carbon future. And in that spirit, I truly welcome you, and I think I'm very happy that we have been able to gather together at fairly short notice this particular symposium to not only celebrate the startup of the architectural engineering program here at University of Waterloo, but also that we will be in a new building, Evolve One building, which is a net positive energy building, the first one in Canada here on the University of Waterloo campus. Dean Andrey might touch upon that as well. So it is my pleasure to welcome you. Enough said from myself, and I hope that the discussions and the presentations will shed light on how collectively we might move towards what is a future with some positive insights on what buildings can do as part of this transition. Thank you. And now I would like to call upon Professor and Dean of Faculty of Environment, Jean Andrey, to make a few remarks. Thank you.
Well, good morning. Thank you for coming out on this rainy day. Earlier this month, the IPCC the Intergovernmental Panel on Climate Change released a report which some of you probably either have looked at or perhaps heard coverage of in the media. And it was entitled Global Warming of 1.5 Degrees. And if you look through even the executive summary, it makes two things very clear. The first is that humans have contributed in substantial ways to the warming of our atmosphere, with all the consequences that come with that. But the report, as a second point, also reminds us that reaching and sustaining net zero global anthropogenic carbon dioxide emissions and declining net non-CO2 radiative forcing would avoid further anthropogenic warming. In other words, if we act now, we will learn to cope with the warming that we've created without worrying about the dangerous interference that might have consequences that are more difficult to address. So the whole point, I think, of us getting together here today is that to explore the innovations in building science that can be integrated into the very fabric of the development of the construction business. And you, of course, are leaders and experts in that area. As noted by Dr. Jatin Nathwani, this is an exciting symposium, and it's particularly exciting because we have so many industries here, so many companies here who are on the forefront of making things happen. You know, in the academy, we have the advantage of being able to sit and think and write and share. But you have to do it. And so that's why it's so wonderful to be able to have this dialogue where we get together. I'm really here to bring greetings on behalf of the university and also on behalf of my own faculty. So my faculty is the Faculty of Environment. We are Canada's largest faculty or school of environment, and we are interdisciplinary by nature and committed to sustainability at its core, as we were for the last 49 years since our inception. So we bring together people of different backgrounds, people who have got environmental science, engineering, business, technology, social science background, and these people come together around addressing core challenges like the one we're facing on transition to a low-carbon economy. But of course, we are just one of 6 faculties here at the university, and all 6 faculties are engaged deeply in some of the grand challenges of our time. And Jatin has already mentioned, but I really want to highlight that the launch of our architectural engineering program with its strong focus on green buildings is just really a landmark achievement for the university, and we feel a contribution to all of Canada. As well, I want to share that as the building industry is on its journey, the University of Waterloo as an institution of higher learning is also on its own journey of sustainability, and we all have to continue to figure out how to do it right. But examples include here, we've recently adopted a campus environmental sustainability policy. We now have a sustainability strategy. You might be aware that my own faculty has a LEED Platinum building, Environment 3, and as noted by Dr. Nathwani, the new build by Cora Group on the North Campus, which is the first multi-tenant net positive energy building in Canada, we've taken out leases with them. So both as a faculty and as research institutes, we will be present there working with the Accelerator Center, working with the community, working with Wilfrid Laurier, and working with industry partners to try to accelerate clean technology and also green building technologies. And so we're really excited about that. We're also really excited about something we did in May of this year, and that is we launched the Canadian chapter of the Sustainable Development Solutions Network. So this is a United Nations network of more than 850 universities and colleges that are working together to try to do applied research and training as it relates to sustainability. And so lots of things are happening here, and we of course continue to challenge ourselves in the same way that I know the industry is challenging itself. So again, just let me thank you for coming. Thank you for gracing us with your presence. And now I would like to introduce our first keynote speaker. So the speaker this morning, that's to start things off, is Craig Applegaff. Craig is the founding principal of Dialogues Toronto Studio and a passionate designer who believes in the power of built form to improve the well-being of communities and the environment that they're part of. Since graduating from the Graduate School of Design at Harvard with a Master of Architecture in Urban Design, Craig has focused his energies on leading innovative planning and design projects. as well as his advocacy of sustainable building design and urban regeneration and symbiosis. Craig's area of practice includes the master planning and design of institutional projects, including cultural and museum, post-secondary, healthcare facilities, as well as the design of innovative industrial and manufacturing facilities. Craig's a founding board member of Sustainable Buildings Canada, a past president of the Ontario Association of Architects, and the current moderator for symbioticcities.net. He's lectured or taught at Harvard, at Toronto, at Waterloo, as well as many professional and sector-related conferences around the world. And in 2001, he was made a Fellow of the Royal Architectural Institute of Canada for his many contributions to the profession of architecture. We're so pleased to have Craig with us today, and with that, I'll bring him to the stage, please.
Thank you very much. Thank you very much for that kind introduction. So, thank you for coming. It's a rainy day to come out to a symposium. When I saw the original topic for this symposium, I thought, wow, this is a really great opportunity to talk about a project that I'm very, very passionate about right now. And I think fits in nicely to the symposium topic, and that's Innovating to Survive, Exploring the Future of Carbon Capture in the Net Zero Hybrid Wood Tower Prototype. And it's a prototype because we don't have a client yet, but we're getting there. So, innovate or die. This is the famous or infamous quote from Peter Drucker, a management consultant, business consultant. And he basically said, unless businesses continually innovate, they'll become extinct. Hands up, how many of you feel the pressure of innovation now more than ever? Right? So that's a very negative way of casting this, innovate or die. Although you're not alone. When you Google innovate or die, 23,300 search results come up. I mean, people that have searched for this. So it's certainly on everyone's mind. But there's a, a more positive way of looking at innovation. Of course, a quotation from Steve Jobs, innovation distinguishes between leader and follower. So you do have to innovate or die, but if you do innovate, you have a chance to become a leader in the industry. And that's not just great because you're known as a leader, but it means you can shape where things are going. You have some opportunity to shape your destiny and the industry that you're part of. So what I'd like to talk about today is three things related to innovation. First of all, I'm going to set the context of innovation at Dialogue. This is not to brag about Dialogue, and I'm not going to show a whole bunch of pretty pictures that architects usually show when they come up and give a presentation. But I just want to give you a context of what we think about innovation and how it drives us. Then I'm going to talk a bit about the hybrid wood tower prototype that we're working on right now, and why we're working on it, and why we think it's important, and why you might want to think similar projects are important. And then some thoughts on innovation itself, the process of innovation and how you can actually spur yourself to be more effective in innovation. So first of all, at Dialogue, innovation is a big deal. We're actually really scared right now about the rate of change. What scares me the most, and I'm trying to scare my fellow partners as much as I'm scared, is AI. Have any of you read Tim Urban's blog on, if you haven't, go read it. It's called What But Why, or Way But Why But What. And the rate of innovation in AI is exponential. And we're sort of here, and we're about to go hockey stick with AI. And we'll have an impact on all of what we do in the construction industry, in the design industry, planning, engineering, interiors. So that alone should be spurring us to innovate. But as pointed out by Dean, we also have to deal with the reality of climate change, and that's even more scary. So for us right now, innovation is driving us from behind us as a fear of extinction, but also because we realize we have some important tasks at hand. So who is Dialogue? For those of you that don't know, we're a collaborative of urban designers, planners, architects, interior designers, structural, mechanical engineers, and landscape architects, all collaborating together in one studio or in 5 studios, but in each studio there's that integrated group of people to do one thing, to meaningfully improve the well-being of our communities and the environment we all share. That's what we use as the way of deciding what work we take. If we can't do that, we don't do the work. And if we do the work, we try and figure out how we're going to accomplish that purpose. That's what drives us. And for us, innovate or die translates into investing in research. And I'll give you 3 examples that touch what I do as an architect and urban designer. In the last 2 years, we've invested in the Community Wellbeing Framework. That's the colorful wheel up there. I'll talk a little bit more about that. The AIA 2030 Challenge, and when I say invested in it, it's not meeting the requirements of 2030 Challenge, but all of the infrastructure, the intellectual infrastructure we have to set up, the energy modeling iteratively on projects that we have to force ourselves to do in a way that we haven't done before as rigorously on all of our projects, and the testing of all our projects against that mandate. So that requires a heck of a lot of investment in time and energy, which we think as research. And the third one is a more personal passion project, and that's the podcast I launched last year. So for community well-being, we teamed up with the Conference Board of Canada. And by the way, and to give you a sense of the cost of doing these things or the value, we've spent in the last 2 years about $1 million in investment in research, and that's time and expenses. So we teamed up with the Conference Board of Canada. They actually did the hardcore research. Architects and engineers are not good at this kind of academic research, to figure out the kind of indicators that we could actually use to determine whether or not we were actually improving the well-being of the communities and the environment they're in. Like, it's easy to say it. In fact, one client said to us, oh, all of your competitors say the same thing. Well, that's a good thing, actually, that we're all thinking the same thing. But how do you know you're doing it? So we came up with 5 key indicators, or a number of indicators under cultural, political, social, environmental, and economic categories. And outside that ring is a set of metrics to determine how effective we've been. And so now all of our projects, our urban design projects, our interiors, our building projects get tested against this to determine whether or not and how successfully we're actually meeting our goal of improving the well-being of communities. The AI challenge, of course, is to get to net zero buildings by 2030, which used to sound like a long ways away, but it's actually only like 22 years away, right? So how do we do that? Because most of our clients aren't interested in doing this. We've got some really proactive clients, like University of Waterloo, going for their net zero buildings. We've just finished one net zero positive building. But for the most part, they're stuck in the economic reality they see today and can't do it. So how do we get there? And the third project, and it's the investment of time, is in a podcast where I'm interviewing one person a month. And when I started last December doing it, I thought that would be easy, and it's actually taken most of my weekends of this past year preparing and interviewing and so forth, where I explore with the guest, and the guest, architects, engineers, politicians, people that are in some way in their professional lives or their lives dealing practically in some emulatable way with harm reduction, pulling back on the carbon emissions, adaptation to climate change, and regeneration of the damage we've already done. So those 3 things really form the context for the way I work in the world, and my partners there's other research initiatives going on, so we're all sort of trying to figure out how we can look to the future in designing the projects we're doing now. So here's one of the projects that I'm leading. And when I say leading, I mean I'm sort of like a herder of cats. I'm trying to get all the people together because this is a passion project. There's no client right now. This is what we do on weekends and in the evenings. So it's like herding cats. So we're designing a net zero carbon, net zero water hybrid wood tower of over 100 stories. So what we do when we start any project is we ask the question, and when we're dealing with a client, we ask the question, what does success look like? In fact, if you're going to take anything away from this presentation whatsoever today, I'd suggest you take away this question and ask yourselves that of every single project you start, whether it be an internal project, a client project, or something in your life. What does success look like? Because so often we dive into a project with a bunch of assumptions given to us by, our professional past, our clients, whatever. But asking yourself, what does success look like, all of a sudden starts to create a set of questions that might take you out of the ordinary. So the answer for the hybrid wood tower was not the most wood, it was the highest volume of wood stored per dollar invested. So how can you actually store a lot of wood in an economic way? Which equals how the highest volume of carbon stored per dollar invested. And not the tallest all-wood building. Right now, there seems to be a trend, a fad, to seeing how tall we can make an all-wood building. And it's sort of like a fun game. Right now, it's 22 stories or something. Okay, but why? Like, why does it have to be all wood? What's the point of it being all wood? That's the question we asked ourselves. What are we trying to accomplish here? All wood to just show how, as engineers and architects, we can do all wood? Or is there a point to having a lot of wood in a building? And so here's the answer we came up to with. The answer to that question was a 100-story plus hybrid wood mixed-use high-rise prototype that answers this question. How can we design a mixed-use high-rise building using wood, steel, concrete, and other advanced materials, carbon fibers, etc., that maximizes the overall use of sustainably harvested wood by volume? Again, that maximizes the overall use of sustainably harvested wood by volume in high-rise construction in the most cost-efficient, energy-efficient, water-efficient, low-carbon, and elegant manner that also is conducive to human well-being and the well-being of the environment. And the reason that we were focused on this is because the all-wood building goal is not economical. It's not economical to have all wood because wood has some limitations in terms of its compressive strength, its tensile strength. And so the point is not all wood. The point is to get as much wood into the building, sustainably harvested wood. Why? Because when you take sustainably harvested wood out of the forest and you harvest it sustainably, that means you're not clear cutting. What that does is it draws more carbon into that forest. It provides light in the canopy, and the trees that are there start to grow more and suck in more carbon. So not only are you locking up carbon, you're actually entraining more carbon into that forest. Right now, clear cutting of forests causes 20% of the carbon emissions in the climate. So if we can create an economic model, a flywheel of sucking sustainably harvested wood into buildings, then we can actually reduce carbon emissions from clear cutting and actually sequester carbon in forests. So the whole point of this is forest management. Sustainable forest management, and the way to do that is the construction industry, the building industry can be the sort of place to put it. Right now we put it in houses, in single-family houses, and we can put it in 2 or 3 story buildings now, up to 6 story in Ontario. But what do we do for tall buildings, especially tall buildings in Asia, where the population actually needs to be accommodated in taller buildings? So this project included not just us, but we reached out to Ellis Don to partner with because of the ability for them to give constructability engineering advice, which is key to resolving this problem. RWDI for wind loading issues, ARUP for fire safety and exiting, RDH for building envelope and building science, and Morgan Solar for PV renewable energy. So why a hybrid wood structure? These are the sort of key rationale points that we came up with. Structural capacity is increased. You get to use different materials to their best advantage. The actual volume of wood is increased. because you can have a greater number of stories. Even though you're not using as much wood per square foot of building area, a taller building means overall volume of wood is increased. FAR and GFA are increased. Program flexibility. If you can use steel as well as wood and concrete, then you can have larger bay sizes. Life and fire safety is enhanced. And probably the most important one, as it turned out, as we sat down with the logistics guys at Ellis Don, we found that although concrete floors are less expensive in material, concrete takes about 3 days of floor to form, pour, and then strip. Whereas wood, you can swing into place and do a couple floors in a day. So all of a sudden, the labor cost goes down, and the speed of delivery goes up. So the overall economic value equation works better. So here are some preliminary concepts. And I've got to say that usually we would not show such crude drawings at this stage, but this symposium didn't line up when we were finished our early renderings. So excuse the crudeness of this. This is the idea right now. It's a mixed use tower, a pair of towers. There's a residential tower that's 130 stories tall. And then there's a commercial tower that is 70 stories tall. And then at the base of the building, there's a platform, a podium, in which we're doing cogen. We have a bioreactor to suck out the carbon from the cogen, and we've got commercial retail going on for street level. So basically, the podium of this building is going to interact. Once we have a site, this is sort of amorphous and not very defined, but it's just got to interact with the street grid and with the street face in such a way that it's going to contribute to the street. It's going to be 3 or 4 stories tall, possibly up to 5, depending on what's happening with that street face. And then above it and set behind it is the towers. The top of the building has this small amount of PV on it, certainly not enough to power more than a couple of floors below it, but the whole of the building skin on the south, east, and west sides have integrated PV in them. The floor plans are very simple. There's a concrete elevator core, structure core. The thickness of that is about 1 meter on the perimeter, with steel columns on the outside to stabilize the ring trusses. And this is the innovative thing going on here. This is the thing that we came up with after playing and experimenting, exploring. We've got 9 floors of wood, and then 1 floor, a large depth floor of a ring truss attached to the steel columns on the outside and to the concrete core. And the ring truss supports the columns and wood above it. And that goes and it also provides a way of separating those 9 floors from the floors above it. If you know, with wood has a bigger issue with creep. So at 9 floors, you can deal with the wood structure, and it's not really creeping that much more than that would cause problems against the elevator shaft and so forth. So there it is, sort of the logic of this. There it is, sort of set out as a structural diagram. The building envelope strategy, where's John Strobe? I just make sure I can avoid him if he starts to jump up and yell and scream. Because every single lecture I've ever been with John Strobe, he says, double skin envelopes are stupid and a waste of money. And he usually has some explicatives in there as well. But we're actually going to be using a double skin strategy here. And we're doing it for a couple reasons. One is, as we started to talk with developers, and Cadillac Fairview is going to be our peer reviewer on this, is that the commercial retail environment, I mean the leasing of space right now for commercial is such that they want all glass. And you can't get a low energy building with a typical triple glazed argon filled glass, but you can with a double skin, even though the double skin costs twice as much. We've just finished doing one in McKimmie Library in Calgary, and it literally costs twice as much. But here, it's also got to do with our fire strategy. The wood is supporting the outside skin, But more importantly, it's how we're integrating PV into the building. On the residential strategy, we're using an internal balcony, like instead of, you can't, that high, you just can't have balconies in the building, it's terrorizing. But if you have that balcony inside, it becomes a double skin, then you're using the balcony as that double skin and an actual rentable space or saleable space. Here's the carbon strategy. We are looking at both operational carbon and embedded carbon. And the embedded carbon is the amount of carbon in the wood that we're putting in the building. So this is the back of envelope calculation for this first go, because we haven't worked out exactly the type of structure we're going to be using. Probably on the commercial building, it's glulam planks connected together to create the deck, because the spans are greater than residential, and residential is probably CLT, or we're talking to some people down in Oregon about plywood that's this thick, which is really cool. But there's only one supplier of that, so right now, maybe not. So right now, this set of buildings sucks up and stores 16,000 tons of carbon. And when you think of that, that's taking all that carbon out of the forest, and that means that will be replenishing itself in the forest after this is locked up. So this is a storage system for carbon. What we typically think of is operational carbon. And the net zero strategy for carbon in the building relies on things like the residence is a net heating building, and the commercial is a net cooling building. So with, say, ice storage, we can use the heat from the commercial building that's stored up to heat the residential building. And the building and the cooling that the cooling of the commercial building will produce heat for the residential building, and the heat for the residential building will produce cooling for the commercial building. We're working with Morgan Solar. Any of you guys know Morgan Solar? They're a very cool Canadian company right now that is doing some really smart stuff with PV. And this is the Sun Simba system is a tracking system, so this will go in the double skin there to track the sun and collect energy for the building. The other thing they've got, which we'll use in the residential building, is these Venetian blinds, and this is not actually public yet. They gave it to us and said, as long as this doesn't get stored on someone's computer, it's only on yours, you can show it. And these are Venetian blinds that have a special kind of plastic on it that brings the light down into you can see a little gray strip in the middle of those clear Venetian blinds. That's a little piece of PV, so that it actually makes it extremely efficient, yet you can get light through those Venetian blinds. So you can close the Venetian blinds, and you can dim the light, but you get light still through, open them up, and then see through it. But I think the coolest technology that we're going to be using, and one of the reasons I wanted to be involved in this project, is I'm doing everything I can to publicize this technology. This guy standing in the middle is Steve Martin, the CEO of Pond Technologies. Hands up, how many of you have heard of Pond Technologies? Okay. This is after I sat down a couple years ago with Steve for lunch, because Peter Howard, who we're going to mention a little later on, introduced me to him. The hair on my back, my neck was standing up, and my heart was racing, and I thought, oh, fuck, we've solved climate change. Like, oh my God. And so what's happened over the 2 years is just watching how hard it is for really smart technology to get traction when it's so out there. And yet it's very basic. What happens is this bioreactor that they've put together, you bubble the emissions from any fossil fuel emitter: coal, natural gas, cement plant flue gas, steel, manufacturing flue gas, any fossil fuel emitter, and you put it into a bubble up like an aquarium bubbler through this big tank of water, and in the water is algae, different strains of algae, and those things, those white things there, those are the backs of big, huge LED lights that go into the tank. And they light at a certain frequency, and the little algae grow like stink, and what do they eat? Carbon dioxide. They also eat NOx and SOx, right? Like nitrous oxide, nitrous dioxide, et cetera. So they purify the emissions, and they take out the CO2. And what you get is from the stack gas, you get this goop, this algae. You think, when I heard it, like, so what, algae? Well, even though I'm a biologist by training, I knew about it. It's really valuable. You can eat it. You can feed it to cows and pigs. You can repair damaged soil. And what they've done now, and they've just opened, I was at the sod turning 2 weeks ago in Markham. They got together with Markham District Energy, and they're now doing a nutraceuticals plant, which produces a specific type of algae, which is very, very valuable, like hundreds and hundreds of dollars an ounce. So this is a way for us to have fossil fuels until we have renewables at a point where they can take over. Time's flying. So some thoughts on innovation. I was thinking that the key thing about this conference is not just what we're innovating, but how we're innovating. So I thought I'd share with you some of the things that we do at Dialogue to help spur innovation. You can't just say to people, innovate. Like, it doesn't happen like that. It's sort of a circuitous process. And you're not always sure how or when you're going to get there. So we deploy a few questions to ask ourselves to help us potentially get there. So again, what does success look? Start out by asking, like, what are you trying to accomplish? What does that mean? Like, that's where this came from, that question. One other question that's worth asking is, what's missing from this discussion? Typically, the discussion runs along tracks, and if you're not careful and ask the question, what are we missing from this question? You might miss the key thing, and I'll give you an example. When we were talking to Ellis Don about the hybrid wood tower, I had no idea of what determines the height of tall buildings, like high-rise. Hands up, do you know what determines the height of a tall building? It's not structure, it's not geotech, and it's not the cost of building it. What it is? It's crane time, right? What? Well, as higher you go, the higher the wind speeds are, and the less time a crane can be in the air. So if the crane can be in the air less and less, it goes higher and higher, then there's a problem because you can only have 40 weeks to build because the money will only be put on deposit for that long. You got the 40 weeks and it limits the time because of crane count. So for us, all of a sudden, we sped the whole process up by using wood instead of concrete floors. Boom. There's the economic argument right there. That solved the problem. The hybrid wood tower we're showing you would not work, especially with John Straub's hated double skin walls, because they're twice as expensive, unless we had this, which changes the game. Another thing to ask is, who's missing from the discussion? So as we started to think about it, we said, well, we're not experts in wind speed, we're not experts in fire, we're not experts in building science, and we're not experts in PV. Who do we need at the table? So that's how we built the team. Another question that we ask ourselves is, how would fill in the blank approach this problem? It's hard as someone that's been working on problems for a long time to step outside of your own way of thinking. And by asking this question, it sometimes helps. This is the guy who sits on my shoulder, and I think my late partner, Tom Sutherland, and best friend, how would Tom do this? How would Tom think of it? Because he was way more practical than I was. I tend to be like big ideas, and he's like, well, yeah, but what about this, this, and this? So I try and channel Tom when I'm thinking of a problem, because I know that if I'm trying to think the way he would think, I'm going to think differently than I typically think. So who's missing? Or how might someone do this? Is there an opportunity for an ideas workshop? A lot of people say, oh, it's a waste of time to get a bunch of people together. But more minds are better than one. This is a workshop we did with Mohawk College the other day. RWDI and ourselves are talking to universities and colleges about having a zero carbon roadmap for themselves. It's not as popular right now in Ontario, as it turns out, than it was under the Liberals, but nevertheless, carbon is still an issue. So this is a post-up where everyone brought ideas about what kind of projects or initiatives would actually help reduce carbon from all over the campus, different types of people. and you put it on this timeline against the kind of carbon it reduces and talk about forcing factors and so forth, and all of a sudden, you've got interaction with people talking about how those projects can interact. It wouldn't have happened unless you brought them together and sort of have them looking at the results. Can you draw a clarifying diagram to explore the problem? Now, maybe this is too architect-y for you, but for me, drawing a diagram that sort of explains the idea I have at a time, and then I pin it up on my desk and sort of think about it, it helps clarify it, because sometimes, for me, ideas are like ping pong balls in my head that are going all the time. But how do I actually clarify that one idea, and then maybe it's not the right idea, but it gives it some clarity. And similarly, could napkin sketches help to explore new ideas and goals? And I say napkin sketches because napkins are really brutal to draw on, and they make really messy sketches like this. This is a napkin sketching exercise we had at a principals retreat a few years ago about how we were actually going to get to doing net zero buildings. And the red circle is my napkin sketch because there was a wood tall building. No one was interested at the time. So are there possible integration strategies? And the best example is what we just talked about, which is Morgan Solar integrating just a simple domestic Venetian blind with PV. Like, when you see it now, it's like, duh, but no one was doing it before. Can you combine constituent parts in new or unconventional ways? I love Marcel Duchamp's work. It was cuckoo. Like, he was just basically saying to the French art community at the time, screw you, like, you're so serious. Take a look at this. This is a urinal on the wall as a piece of art, or this is a bicycle wheel on a stool. And what this also does is it says, why would you ever put a bicycle wheel on a stool? Well, in this case, it's for art, because it's saying this is not typically art, but now it is, because we've done this. But then you say, well, why would you put ring trusses every 10 floors? Like, how do you use technology that is common in a different way? So if you just ask yourself, how can we integrate things? How can we put things together in a way that we wouldn't, and does it give us something? Even though it might not result in a positive thing, it will get you thinking. And then, are there any precedents that might provide insights? Like, for me, one of the projects that we did a few years ago out at the University of Calgary, Eel, is a real precedent for me because it had so many things going on it to get it to be the low energy LEED Platinum building that it is. We just are finishing right now the McKimney Tower, which is a net zero building, double skin. We took an existing old tower and reclad it, and now with the other associated techniques that are going to be used will be net zero. And then another one that I love is the project we did out of our Vancouver studio with the Student Union building, the sub. And that, to me, gave me ideas about how to use wood to support the curtain wall. And then one of the things that's been giving me a lot of ideas is as we work with universities and colleges on the low carbon campus roadmap, the ideas that come out of those are applicable elsewhere. And then one of the ones that I'm most proud of, I guess I lied because I am showing you some pictures of our work. But this is the Bill Fish Forest Stewardship Education Center, and it's the first living building challenge, all 7 petals. And by the way, the materials petal is hell on earth, but important. And it is a net positive producing building. So final thoughts. Innovate or die. I think whether you're up against the wall knowing that you've got to innovate, or whether you're going to be a leader in innovating, I think there's a more powerful reason for thinking about innovating, and that's one that Victor Hugo once pointed out. And there is only one thing stronger than all the armies of the world, and that is an idea whose time has come. And I think sometimes you hit upon an idea, you create an innovation which has a real power to change the world. And I think I have been very lucky over the past year in putting these podcasts together in being able to interview people that are doing really, really smart things that change the world for the better. And an example is the latest episode, episode 10, Peter Howard, who works at Pond Industries, and he was the one that introduced me to the CEO in the first place. And he, like I, was a biologist to start with, and then he became an environmental planner and did a lot of the policy for the Liberal government in their climate change policy, then worked for PwC, and then he got hired by Pond to do their sustainability strategy. But what I took away from people like Peter is the power of a really innovative idea to change the world for the better. And ultimately, that's what we've got to do. I mean, we've got to make a living, but we also, given the challenges we face, the imperative of the 21st century is we've got to figure it out. And innovation is the way to do that. And if you'd like any more information about the hybrid wood tower, you can send us an email there, and we'll keep you posted. That's it. Any questions?
So ladies and gentlemen, we have 3 microphones right now, 2 not very portable ones and 1 extremely portable. So if you are too shy to come to the non-portable ones, I will be more than happy to approach you guys. Questions? Oh, yeah, there's one.
Yes, okay.
One simple question. Are you thinking about geothermal energy, heat beneath the ground, as part of the thinking of new buildings and potential source of energy
Yes.
beyond solar?
We're doing a project right now for the federal government, the old postal station on St. Clair, 2555. And we're using geothermal to basically shift the heat load by season. So in the winter, we take heat out of the ground for heating, and in the summer, we put the heat back in the ground when we're air conditioning it. So for this building, we're looking at what will make the most sense. The problem with starting with geothermal as a strategy when you don't know what your site is you don't know the storage capacity of the soil. But yes, it definitely is something we want to do. And what we'll do as we move forward is have a series of strategies that we could be deploying. And if the idea is to create a prototype that's more applicable than just on one site. So yes, geothermal is for storage of heat, and transferring heat load over seasons is a very, very powerful strategy. Anyone else? No? Yes?
Hi, I enjoyed your talk very much. It was very engaging.
Thank you.
You're welcome. Thanks for having us here, too. Just wanted to ask a question. What is your biggest challenge to move forward on innovation, personally and as a company?
Personally or as a company?
You personally first, and then
Okay.
a little bit on your company.
I think the biggest challenge is not coming up with ideas. It's sometimes figuring out which ideas will have the most purchase and are the most relevant to solving the big picture problems. So for me right now, at this point in my career, I think the most important thing I can do is come up with ideas that move us in a direction that adapts to climate change, pulls back from emissions, and helps regenerate the damage we've done. So everything, I filter through that lens. And I think for the firm, it's allocating resources to doing the research we need to do for staying on top of the innovation game. And things are getting faster and more furious. So I just came from a strategic retreat last week, and we voted as principals, we were 50 of us, 50 principals, to increase the size of our research budget. Because in the last couple of years, we spent $1 million, and we realized that's not enough in order to really have the tools and techniques we need to make the changes in the world that we know our clients we'll need. And most of our clients aren't asking right now, but we know they will. They're starting to, so we have to be ahead of that game. So the challenge is, and another challenge is friction, is the friction of the world just like pond. Like I thought it would be, bam, we've solved climate change. No, it's like no one seems to care. So go figure. So friction, yeah. Oh, okay. Okay, who's first? Okay.
Hi. So my question is, you guys have obviously calculated the embedded carbon in carbon stored in the wood in your tall wood building or hybrid building. I was wondering if you looked at like overall embodied carbon on like a net scale for the construction of the building in all the materials.
Oh, okay, so the answer is we haven't calculated that yet. And here's the reason why. Well, we don't have a lot of time, but the reason is that if you use a bioreactor, you can have zero carbon concrete and you can have zero carbon steel. So all of a sudden it changes the formula for that. So we would say one of our assumptions is that we can have the pond technologies strategy to, they're teamed up with St. Mary's Cement right now. So it won't be long before St. Mary's Cement has zero carbon cement to make concrete with. They're teamed up with Stelco. So it wouldn't be that long before you could have zero carbon steel. So I think those are the things that are in flux right now. So what we're doing is we're saying that's in flux. We are not going to make a calculation because anyone can do that on any building. So do it. What we're trying to do is figure out how to get the wood from a sustainable forest into the building in the greatest volume. That's the game we're playing. And the rest of it is good old-fashioned smart building science.
Thanks.
Thank you. I think he's next. No, she's, oh, sorry.
Hey, so I was wondering if you could talk a bit more about the double skin facade you mentioned. This is something we've seen more in Europe, but I know that there's not as much in North America. So I was wondering from your experience, I get that you said it's double the cost, but what about, effects on natural ventilation and impact on energy and comfort? Does that really make a sense for occupants and operational cost, or is it just really expensive and not feasible here?
Well, I'll tell you, it's as John would point out, in Europe, where they have a climate that's more moderate than we have, it makes more sense economically. We're using it because although it costs more, it allows us to integrate PV into it in a way that doesn't take away from the tenants' appreciation of their space. And tenants, commercial tenants, are demanding that kind of glass. So it's sort of like, well, if we can make the economic argument for being able to build a building like this and use that, we will, right? So it's a titchy problem, and I'm not a big, yeah, you have to do double skin. We should have 25% glazing and 75% wall that's well insulated with no thermal bridging. That's my stand on building when I talk to clients. And if a client says, yeah, but we need to have double skin, I say, okay, you got to pay twice as much. You get some benefits of mechanical, but understand what you're trying to do. So I'm not a proponent of that per se, but there are reasons to do it. Like if you're going to use, if your building is a renewable energy generator, that's a different game, right? Hi.
Yeah, good presentation.
Thank you.
Just on the premise that we build buildings for people to live in and to work in, because there's people inside of them, what parameters are you using for thermal comfort? I mean, energy is great, low carbon is great, but ultimately for a person to be comfortable and to be healthy in the building, are you looking at thermal comfort parameters, ASHRAE 55, stuff we've known about for 40 to 50 years, as the building designers, or are you leaving that to your mechanical people to figure out?
Well, we don't have mechanical people. We have integrated mechanical engineers that are actually designing the building with us.
Okay.
So what we sit down and say is, what standard will we use to do it, understanding that they're probably different, depending on where this thing gets deployed in the world, there may be different standards. Like in other parts of the world, people are willing to have much more range and thermal comfort. When we're doing the federal government building, if you go beyond a certain range, people get to walk out of their offices.
Right.
So I think these buildings can be tuned to any standard you want, but we want to make sure that it can meet the highest standard. Does that make sense?
Sure.
Okay.
Yeah.
I sort of deked around your question in a way, but I think there are a number of we're saying, well, it's got to be open to be used in different ways.
Yeah. Sounds good.
Okay. Thanks for the question.
So I guess we can take only 2 more questions.
Okay, 2 more?
So, yep.
Looks like there's only 1 more. Oh, 2 more.
Okay, I guess this comes from some things you've already answered from the questions, and that's looking at other construction materials, and particularly the concrete. And the words I've heard these days is sequestering CO2 in concrete as a means of reducing greenhouse gas.
Yeah.
Any comment on that?
Yeah, it's a smart thing to do. I think right now we've got 408 parts per million of carbon in the atmosphere. We're at 1.5, higher than we were like 4 years ago. We got 5.5 degrees before we cook. Anything we can do to pull carbon out of the air should be considered. Forests now clear cutting of forests around the world account for 20% of the carbon dioxide being emitted, because what happens when you clear cut a forest is 60% of the carbon that was stored, it's stored in the ground, it comes out. So we have got to figure out techniques, integrate our world, building world, with that natural world, and one of the most effective ways to do it is to use carbon. So yes, sequestering the carbon in the building, but it's not just storing it there. It's like if we create this flywheel of sucking up sustainable forests. By the way, if we go and do this with non-sustainable wood, this is a disaster. This is going to put more carbon into the atmosphere, so it's got to be sustainable. Then we're going to contribute significantly to lowering the emissions. So that's why do this. It's not about making a tall wood building. It's about creating a mechanism to get the carbon drawn out of the atmosphere from our forests, phenomenal machines for that, and then in. So thank you. And one more question?
I guess 1 more question, and then we have to stop. Okay.
Thank you for the presentation. So this is a very background question.
A very what?
Very background question from
background.
my knowledge. I guess you a little bit discuss it right now about the sustainable forest, but like because I'm lazy, I didn't Google it, but my question is that how much the construction industry has the footprint on deforestation? You already mentioned that we should do sustainable forests, which I don't have any background on this, so maybe you just give me some image of how this industry has impact on deforestation.
Do we have another hour?
Oh, okay.
So,
Sorry.
So I can't tell you what Canadian or Ontario industry uses non-FSC wood, Forest Stewardship Council wood, versus it's not super high now. I think what we need to do is move towards it, and one of the ways to do it is to show an economical way of using FSC wood, because it's more expensive than just wood from clear-cut forest, right? So this is the machine that will make an economic argument for FSC wood. Yeah, thanks. Thank you very much for your patience. It was a lot of fun.